Okay, I'm Phil Warren. I'm a color scientist and computer vision specialist based in Los Angeles. For my day job, I help film, television, and video game companies capture and display imagery. And in my free time, I do pretty much the same thing, but stupider. Now, I wanted to change things up recently. Sure, we see dazzling images on a huge silver screen. They make Nicole Kidman's mind real. And yet, I crave something more. What if there were a way to capture an image and emblazon, emboss, ink, or otherwise commit to a physical medium like a sheet of paper? A ridiculous dream, I know, but surely there's a way to put an image on paper. Now, the ink alone would cost nearly $10,000 a gallon, so this is a fool's dream, but if some magnificent machine could do this, we could even make a flipbook and create video. And that led me to conclude that obviously we need to use a typewriter to do this, from 1971, and then find a way to make both images and video with it, which is the problem we're trying to solve today. Today, we're going to get images from a 1970s typewriter. Now, the first phase is simulating our idea poorly. Now, I'd made works of art for a show at the Dark Art Emporium 2 years ago where I downloaded 500,000 NFTs, more fungible than the name implies, and used frequency analysis to recreate works of art out of NFTs. What if I did this with typewriter glyphs instead of NFTs? To accomplish this, I used a package I absolutely love with a team on GitHub that has been exceptionally responsive to requests. It turns an image into a mosaic while respecting curves and textures. This image collage maker has a GUI to experiment with, but then it has a command line interface with Python so I can smoothly integrate it into code, imperative if we want to do video. So first I wrote a quick little script that converts a font pack to images. It uses nothing more than pillow, and it names each image with the ordinal Unicode pointer. Now, the ordinal numbers will be very important later. Now, we're going to take this input image because I love it desperately. We run it through the command line interface with a simple Python script, and success! Looks like we can, in fact, use Python scripting to generate a black and white image using this technique, which also gives us a list of the letters used in the order they were used to be typed and recreated on a typewriter. But we can do better. So the second phase is texture in the real world. Now, a little bit about our typewriter. I'm using the Selectric typewriter, which was just discussed. When it came out in 1961, it changed the world. By using a whirling, bobbing ball-like element called a type ball, this single-handedly changed typewriters and computing forever. This type ball not only sped up typing speeds by tenfold, it also, for the first time ever, allowed for typefaces to be changed out of a typewriter simply by replacing the ball. Now, a brilliant optomechanical engineer, Joseph Ballas, had emphatically presented me with a project last year. Programmer Sam Ettinger had finally cracked the nut. Selectric balls could surely suddenly be 3D printed. Could we design our own? Surely it would be madness to try and design a type ball that wasn't ASCII characters, right? And the Adventurers Club, specifically a representative named Andrew McGregor, took an interest in my project. Runic Elder Futhark, a Norse proto-language, would be in high demand in his Scandinavian circles, so I designed some balls, printed them up, and he showcased them in Oslo. It worked. And from this limb of the project, I got a working Selectric 2 and a connection with a resin printer. So I can extend this by feeding a handful of texture font packs into the mosaicing algorithm. I can see which ones were used the most. I limit these to the top 62, leaving space for 26 characters so we can still type, and now we have a custom ball. Now, after 36 hours, oh my God, rendering this to printable geometry, we have a workable glyph ball that can type textures. And don't forget, we recorded the decimal ordinal characters in an earlier step. With only a few lines of Python, we can now generate a cypher in which earlier ordinal characters are translated back into the keystroke that would generate it. This means a human hand can now type this cipher, and the custom glyph ball can type the intended picture. Remember our alphanumeric piggy from the last phase? He's looking much better. It looks like 62 custom glyphs can create an image of a higher fidelity. But we can do better. Our third phase, color. Remember, when we put pigments on a real-world object, we don't see the color the pigment is, we see the color it isn't. Our eyes receive the photons it bounces back, not the photons it absorbs. That means that the more pigments you mix, the less photons bounce back. We call this color model subtractive, where mixing all colors make black. When dealing with modern display tech, we generally think in additive terms, where mixing all colors makes white. And this makes thinking about real-world pigments digitally complicated. Now, normally, we use 4 colors, cyan, magenta, yellow, and black in the subtractive model, but as typewriters can do, at most, 2 colors, we're going to set that as the limit for today's project, 2-color imagery. Now, Technicolor tried to pioneer a 2-color model in the 1920s. As they frantically researched how they could do a full color projection, they came up with some stopgaps to present a sort of pseudo-color to audiences. They figured out that by using 2 colors, they could sandwich the film strips together for a subtractive model. In Technicolor's process 3, they determined that if you only use 2 colors, you should use red and green. Red dye will help reproduce skin tones. Green dye will help reproduce foliage. And blue? There's no need for blue. Perhaps you misremembered the sky anyway. In fact, fuck the sky. Now, King of Jazz is my favorite example of Technicolor Process 3, possibly because it's the only full film in this format I could find. To simulate the capture of that 1920s camera they used, we split an image into 2 channels. Now, as all images are nothing more than m by n by 3 arrays, we just multiply the same input by the RGB values of each given glass filter we're simulating, and the result is what the emulsion surface would have exposed. Next, as before, we just run the Python script to convert to mosaic of glyphs. Next, we simulate the dye imbibation process the film would have gone through in the 1920s. Instead of washing out the soft gelatin in the film, which was black, and replacing it with dye, we use Python to replace the black and with either a salmon red or a mint green, leaving just enough blue in the pigments that when layered upon each other, they create something black adjacent. Then we mix the 2 resulting images in a subtractive process, which is simple multiplication in Mathland. So we go from to this. Success. But we can do better. Our 4th phase is making this electric more electric. Now, around 1983, there was a security leak at the US Embassy in Moscow. When everything was torn apart, the US discovered magnetometers embedded in their Selectric typewriters. When depressed, each typewriter key broadcasted a small electric signal to the KGB, the world's first keylogger hack. We can literally reverse this process, sending a small electrical signal to an electromagnet, having it create keystrokes. Now, this would make a typewriter that types by itself, powered by solenoids. Now, programmer Alan Wilson has already cracked a method to automate the Selector 2. This converts the typewriter into a teletype machine or a proto-printer. Now, my partner in crime in this phase, Joseph Ballas, and I are currently at work on this. But can we do better? Yes, we can. So, phase 5, pipe dreams and future goals. What if we could embed an SMS chip, then text the typewriter? What if we embedded a camera for a surprise selfie? What if we added voice to text as an accessibility feature? What if we hooked up an electroencephalogram and made it brain-powered? And now we see the fruits of my project. Now, this is a flip book simulated at this phase until the typewriter automation gets working, and we see each of the 4 phases. And that's what it is for now, but please slide into my DMs on Instagram, hire me, or get hired by me on LinkedIn, grab my phone number after the talk. Let's chat more image technology. Cool.